All right, let's do a few more examples with concavity. Find the intervals where this function is concave up or concave down and find any inflection points. Okay, this is it's a fourth degree polynomial, and it starts with a positive number, so it's going to be shaped something kind of like that. So we'd expect to have a couple of different inflection points. So let's do this. So we get the inflection points, take the second derivative. So f prime is 12x cubed minus 12x squared plus 1. F double prime is, let's see, 36x squared minus 24x. And if I take that and set it equal to 0, that'll give me my hypercritical numbers. Looks like if I could factor out a 12x. I'm left with 3x minus 2. So that gives me critical numbers of, or hypercritical numbers of x equals 0 and x equals 2/3. All right, let's put them on my chart. All right, 0 and 2/3. Now let's pick our test points. The natural easy things to pick over here would be 1, back here would be -1, and in the middle something between 0 and 2/3, either 1/3 or 1/2. Let's go with 1/2. So now I've got to do f double prime, and above that I'll do f. So let's come over here, f double prime of -1, and I'm plugging that back into here. So I get 36 times -1 squared minus 24 times -1. That's a big positive number. F double prime of 1/2. Let's see, that's 36 times 1/2 squared is 1/4 minus 24 times 1/2. So let's see, 36 over 4 is 9 minus 12, that's negative. You might say, does it always alternate plus minus plus minus? The answer to that's no. Sometimes you will have it where you have two pluses together or two minuses together. So you have to plug in all of your test values. Plug in f double prime of 1, we get 36 minus 24 is positive 12. And so that tells us, let's see, plus. The pluses get smiles, the minuses get frowns. And so this graph is concave up on, let's see, minus infinity to 0, and from 2/3 to infinity. Is concave down on 0 to 2/3. And our inflection points I'm going to use Desmos to get those, but we get the concavity changes at 0 and at 2/3, so we're going to have 1 at 0 and 1 at 2/3. Now let's use Desmos to figure out what those are. Let's see. So my function is 3x to the 4th. I need to put in f of x equals 3x to the 4th minus 4x cubed plus x. And that's the function, and yeah, it does have that sort of W shape. It's maybe a little lopsided, but it's the W shape that I drew before. Let's see, 0 and 2/3. So f of 0, why am I doing that? F of 0 is 0. That's one inflection point. one of our inflection points. The other inflection point is 2/3, comma, something, f of 2/3. All right, so those are our two inflection points. That f of 2/3, I was thinking I could plug that in there and it'd give me a number and I'd recognize what the number is as a decimal, but I don't. So I'm going to stick that in my calculator to get it. Let me show you how I'm going to do that. On here, I'm going to put in 2/3 for x. So I'm going to put in 2/3. So 2/3, and then store. Where's my store button? Right here. Store into x. And then I'm going to put in 3/4 times x to the 4th minus 4x to the 3rd plus x. And that's going to give me for some reason I put in 3/4. I don't know why I did that. It's 3x to the 4th. So yeah, when I actually put the right thing in, it gives me the 0.074 that matches what is on Desmos. And now if I press math button and then 1 to convert it to a fraction, it gives me 2/27. Of course, we could do that manually too, but this is good. So those are our two inflection points. All right, how many more examples do we have? Let's do one more example of this. Find the intervals where this is concave up and concave down and find any inflection points. All right, y prime, we've got to use the product rule here. So we get first times derivative of the second, that's going to be e to the x over 2 times a half, because of the chain rule, plus the second times derivative of the first. Derivative of 4x is just 4. So let's see, this gives me, I can factor out that 4e to the x over 2, and that leaves me with 1/2 x plus, actually, you know what, let's don't do that, because we need the second derivative here. All right, so for this, actually before I even do that, I'm going to write this. Y prime is 4 times a half gives you 2x e to the x over 2, then plus 4 e to the x over 2. Now that I've got that, I can take the derivative of that easily to get y double prime. Got to use the product rule again on this bit. So you get first times derivative of the second, and chain rule again, plus second times derivative of the first, which is 2. Then over here you get 4e to the x over 2, and chain rule, got to multiply by 1/2. So let's look at this. We've got 3 different bits to this. We've got this, this, and this. I was going to factor stuff out, but notice these two are actually the same terms. They're both just e to the x over 2 with the coefficient. So let's see, this first one is just x e to the x over 2. And the others together, this gives you 2 and 2 gives you 4 e to the x over 2. Now I can factor out e to the x over 2. And I'm left with x plus 4. If I take that and set it equal to 0, this gives me no solution. Why is that? It's because it's e to the x over 2 equals 0. That has no solution. E to the x over 2 is always above the axis. This gives you x equals -4. So all this worked, but now we only have one hypercritical number. So come over here. Just going to split this at -4. And I need a number over here and a number over here to plug into f double prime. All right, f double prime of -10. Let's see. Let's plug into this version of it. That's going to be e to the -10 over 2 times -10 plus 4. So that's a positive value times a negative value. This is negative. And f double prime of 0, that's going to be e to the 0 times 0 plus 4. E to the 0 is positive. It's 1. This over here is positive, so this is positive. So my function, f, it's sad, then it's happy. So what we get here is concave up on -4 to infinity, concave down on -infinity to -4. And it does change there, so we have an inflection point at, I'm just going to give the x coordinate of it, at x equals -4. And of course, we can check our work on Desmos. So let's do that real quick. Let's see. I'm going to put in the function f of x equals, let's see, what was it? 4x e to the x over 2. Which looks like that. Yeah, it's got this little wobble in it back here. This is saying that the inflection point is right here at -4. One way we can double check that is put f double prime of x. And if this is an inflection point, that should be somewhere where the second derivative changes sign. And sure enough, it is. The second derivative changes from negative to positive right there at -4. All right. We will stop here.